Hello guys, welcome to my channel. I'm Nelvin James Torres, and this video is all about the summary of Ccna 1 or Introduction to Networks. So, let's get started.
So guys, let's talk about network. So what is a network? Network consists of two or more computers that are linked in order to share resources such as printers and CDs, exchange file, or allow electronic communications. The computer on a network may be linked through cables, telephone lines, radio waves, satellites, or infrared light beams. There are two types of network. First is the LAN, which is local area network, and the second one is one which is wide area network. LAN is a network that is confined to a relatively small area, and one which is wide area network connect network in larger geographic areas such as Florida, the United States, or the world. In exploring the network, you may learn first, network and the internet have changed the way we communicate, learn, work, and even play. Networks come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of a network. The internet provides the service that enable us to connect and communicate with our families, friends, works, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It is made up of network components including end device, intermediate device, and network media. Network must be reliable. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or as large as corporation with thousands of users. The network infrastructure can vary gently in terms of sizes, number of users, and number of types of service that are supported on it. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the foundation of any network infrastructure. There are security threats. The most common external threats to networks include viruses, worms, and Trojan horses, spyware, and adware, zero-day attacks, also called zero-hour attacks, hacker attacks, denial of service or DOS attacks, data interception and theft, identity theft. And also, there are security solutions. Network security components often include antivirus and anti-spyware, firewall filtering, dedicated firewall system, access control list or ACL, intrusion prevention system or IPS, virtual private network, and the internet have changed the way we communicate, learn, work, and even play. Networks come in all sizes. They can range from simple networks consisting of two computers to networks connecting millions of devices. The internet is the largest network in existence. In fact, the term internet means a network of a network. The internet provides the service that enable us to connect and communicate with our families, friends, works, and interests. The network infrastructure is the platform that supports the network. It provides the stable and reliable channel over which communication can occur. It is made up of network components including end device, intermediate device, and network media. Network must be reliable. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or as large as corporation with thousands of users. The network infrastructure can vary gently in terms of sizes, number of users, and number of types of service that are supported on it. The network infrastructure must grow and adjust to support the way the network is used. The routing and switching platform is the foundation of any network infrastructure. There are security threats. The most common external threats to networks include viruses, worms, and Trojan horses, spyware and adware, zero-day attacks, also called zero-hour attacks, hacker attacks, denial of service or DOS attacks, data interception and theft, identity theft. And also, there are security solutions. Network security components often include antivirus and anti-spyware, firewall filtering, dedicated firewall system, access control list or ACL, intrusion prevention system or IPS, virtual private network. There are three types of conversation protocol. One is use a common language. The second one is wait for your turn. The third is signal when finished. Network protocols. How the message is formatted or structured. The process by which networking device shared information about pathways with other networks. How and when error and system message are passed between devices. The setup and termination of data transfer session. There are types of interaction of protocol. First one is application protocol, which means hypertext transfer protocol or HTTP. Second one is transport protocol or transmission control protocol or TCP. The third one is internet protocol or IP. And the last one is network access protocol or data link and physical layers. We began this chapter with a look at the difference between local and wide area network. This was followed by a look at the different type of equipment commonly found on a network, including repeaters, hubs, bridges, switches, and routers. Our look at equipment focused not only on their functions but also their relationship to OSI model. We also covered how the equipment relate to the concept of broadcast on collision domains. Network transmission methods provide a perspective on the three different mechanisms used to transmit data: unicast, multicast, and broadcast. This was followed by an overview of network cabling that included information on cable properties and maximum lengths. We also look at the wiring of crossover and straight UTP cables to connect both similar and different port types. LAN technology was used to gain an understanding of how data is passed over the Ethernet networks. This includes a look at addressing frame types and physical characteristics. Here are some of the definitions. First, router. Router forwards data packets to and receives data packets from the internet. Next is switch. Switch connects end device using network cables. And wireless access point. Wireless access point consists of a radio transmitter cable of connecting end device wirelessly. And last is firewall appliances. Firewall appliances secures outgoing traffic and restricts incoming traffic. Using the CLI, the user interacts directly with the system in a text-based environment by entering commands on the keyboard at the command prompt. The OSI file itself is several megabytes in size and is stored in a semi-permanent memory area are called flash. An older way to establish a CLI session remotely is via a telephone dial-up connection using a modem connected to auxiliary or AUX port of a router. Requirements: Cisco recommends that you have a basic understanding of binary and decimal numbers. Additional information: if the definitions are helpful to you, use these vocabulary terms in order to get you started. First, address. What is an address? Address is the unique numbers ID assigned to one host or interface in a network. Next, subnet. Subnet is a portion of a network that shares a particular subnet address. Next, subnet mask. Subnet mask, a 32-bit combination used to describe which portion of an address refers to the subnet and which part refers to the host. The next one is interface. Interface is a network connection. Understanding IP address. IP address is an address used in order to uniquely identify a device on IP network. The address is made up of 32 binary bits, which can be divisible into a network portion and host portion with the help of a subnet mask. The 32 binary bits are broken into 4 parts. 1 octet is equal to 8 bits. Each octet is converted to decimal and separated by a period or dot. For this reason, an IP address is said to be expressed in dotted decimal format. For example, 172.168.81.100. The value of each octet ranges from 0 to 255 decimal or 0000000 or 11111 binary. Here is how binary octets convert to decimal. The right host bit or least significant bit of an octet holds a value of 2 is raised to 0. The bit just to the left of that holds a value of 2 raised to 1. This continues until the leftmost bit or most significant bit, which holds a value of 2 is raised to 7. So if all binary bits are A1, the decimal equivalent would be 255. Understanding subnetting. Subnetting allows you to create multiple logical networks that exist within a single class A, B, or C network. If you do not subnet, you are only able to use one network from your class A, B, or C network, which is unrealistic. Each data link on a network must have a unique network ID, with every node on that link being a member of the same network. If you break a major network class A, B, or C into smaller subnetworks, it allows you to create a network of interconnecting subnetworks. Each data link on this network would then have a unique network subnetwork ID. Any device or gateway that connects n networks subnetworks has n distinct IP addresses, one for each network subnetwork that is interconnects. In order to subnet a network, extend the natural mask with sum of bits from the host ID portion of the address in order to create a subnetwork ID. For example, given a class C network of 204.17.5.0 which has a natural mask of 255.255.255.0. By extending the mask to be 255.255.255.224, you have taken 3 bits indicated by sub from the original host portion of the address and used them to make subnets, which these 3 bits it is possible to create 8 subnets. With the remaining 5 host ID bits, each subnet can have up to 32 host address, 30 of which can actually be assigned to a device since host IDs of all zeros or all ones are not allowed. It is very important to remember this. So, with this in mind, this subnet has been created. Note, there are 2 ways to denote this mask. First, since you use 3 bits more than the natural class C mask, you can denote this address as having a 3-bit subnet mask. Or secondly, the mask of 255.255.255.224 can also be denoted as -27, as there are 27 bits that are set in the mask. This second method is used with CIDR. With this method, one of these networks can be described with the notation prefix or length. For example, 204.17.5.32-27 denotes the network 204.17.5.32-255.255.255.224. When appropriate, the prefix or length notation is used to denote the mask throughout the rest of this document. Next is the OSI and TCP model. First, OSI model. OSI model, or Open System Interconnection, was created by International Organization for Standardization, or ISO, an international standard setting body. It was designed to be a reference model for describing the function of a communication system. The OSI model provides a framework for creating and implementing network standards and device and describes how network application on different computers can communicate through the network media. OSI model has 7 layers. First is the application, the second one is presentation, third is session, fourth is transport, next is network, data link, and last one is physical. TCP or IP model. This model was created in the 1970s by the Defense Advanced Research Project Agency, or DARPA, as an open, vendor-neutral public network models. Just like the OSI model, it describes general guidelines for designing and implementing computer protocols. It consists of 4 layers. First is the network access, second one is the internet, the third one is transport, and last, the application. That's all guys, and thank you for watching.